Hello there. This is our angle construction activity. All right, let's go for these definitions. What is a geometric construction? Just like the last time, it's when you draw shapes or angles or lines using only a compass, straight edge, or ruler. Accurately, of course. What is an angle? That's a figure formed when two lines, segments, or rays intersect, typically measured in degrees. What's a bisector? A line, ray, or segment that cuts an original angle in half. What does it mean for two angles to be congruent? I'm sorry, I used this one. Both angles have the exact same measure. Okay. All right, so now we're going to talk about how to construct congruent angles. Don't forget, for constructions, you're going to need a compass, a straight edge, and a writing utensil, typically a pencil since this is math class. All right, so here it says to write the instructions in your own words. Please feel free to do that because this is for you. You can also go to this YouTube video that is linked here on the digital copy of this document, and it'll show you the steps as well if this video is not helpful. All right. Okay, so, and also you can practice on scratch paper first just to make sure you don't mess this up because, you know, this is your only copy. Okay, so I'm gonna go ahead and draw a segment for my first step. Okay, now I'm gonna take this and I'm gonna draw an arc. Notice that the point is on the vertex of the angle, and then I just kind of made up a width. There's no specific width that you need to use, just make sure it fits on like the angle. All right, now we're gonna copy that exact same arc down here. Again, put the point on the end point. This is where the vertex of the new angle is gonna be, and then you're just drawing the same width of arc here. The arc with the same radius is what we really call it. And now I'm gonna take my compass and I'm gonna adjust the width to be the distance between, let me just mark it so you can see this intersection and this intersection. So we're gonna bring it down a bit. Boop, 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 boop. A little bit more, boom. So there you go. And now all we're gonna do, I'm gonna flip it around so that the point, not the pencil part, goes here, and then I'm gonna mark here. So you can see this is the same width as this distance, or the same distance as those intersections. And then you can just, shucks. Okay, and then match up your straight edge to the end point and go through that intersection, and it should be the same angle. We're gonna just do a little brief measure test. Hold on, I lost my protractor. Okay, look, I know it's crusty, okay? But she still works, so we're gonna rock with it. All right, so right here, we're gonna put that on the vertex. And we're gonna match up the 0 line with one of the sides of the angle. I typically go this way or whichever side is facing, honestly. Match it up so that it's not like off. Oh, good. Okay, and this looks like it's about 10, 20, 31 degrees, 31, 32 degrees. So now I'm gonna measure this angle and see if it's about the same. Should be the same. Okay, yep. Oops, a little bit off there. Okay, so yeah, this one's off by like 1 degree, but these are both about 31 degrees. Okay, but you're not using this to do the construction. I just did this to check, but you don't use this to do the construction. All right, let's do this one now. Constructing an angle bisector. All right, again, you can use this link or that web address to find a video that will help as well. All right, so again, I'm going to draw an arc through the whole thing. I probably made that a little bigger than I needed to, so I'm gonna shrink this down some. And then I'm going to, yeah, this will work. So I shrunk it down some because I really could have just used the same arc for all 3 of these. But anywho, put it on the vertex, make the first arc. You can adjust the width if you like, but you don't have to. Then putting the point on this intersection, I'm gonna make an arc here, repeat that exact same arc on the other side here, So as you can see, this is on this intersection and then boom. And we honestly are done. Just gotta connect this intersection with the vertex. So I try to do this as accurately as possible. Get your life. Okay. Oh shucks, got stuck. All right, cool. Now it looks pretty good. Let's measure it just to be on the safe side. I'm gonna take my little crusty protractor here and I'm gonna line it up. Don't forget the zero line needs to be in line with one of the sides of the angle. I could do it like that. Or honestly, I could do it like that too. It doesn't matter either way. I'm gonna do it like this though, because I feel like it and it makes more sense to my brain. Okay. Notice that this part of your protractor should go exactly on the vertex. All right. So if some of y'all are wondering, how does she know which numbers to use? Well, I need you to use your sense. Okay, I'm not trying to throw shade. I'm being serious. These bigger numbers over here, these are in degrees. And you should remember from when we did that intro to angle stuff, if an angle has a measure that's greater than 90 degrees, it's what? I hope you said obtuse. This angle is obviously not obtuse. It's acute. So I'm going to use the smaller numbers because that's how that works. If it's acute, the numbers will be less than 90. And if it's obtuse, they'll be greater than 90. So don't be weird. All right. 10, 20, 30, 40, 50. Almost is giving 59. It's giving very much 59 degrees. All right. Okay, so the whole thing is 59 degrees. It's a little bit hard to tell because look. Oops. Okay, yeah, it's like 59, 60. And then this one's pretty much at 30. So 30 and 30 will give you 60. It's close. It's close enough. So I'm going to just round it up. You can put 29.5 if you want to. But yeah, so 30 and 30 degrees. Looks good. All right, so hopefully that was helpful. Bye.